Today we will solve the problem 4.32 of the Griffith third edition Introduction to Quantum Mechanics. The problem 4.32 consists of three parts. We will find the solution one by one. First, the section A is find the eigenvalues and eigenspinors of SY. So basically, the SY matrix is H cross over 2, 0 minus I 0. So if you bring this H cross by 2 inside the matrix, then you will get 0 minus I H cross over 2, I H cross over 2, 0. Now, in order to determine the eigenvalues, you find the determinant and you subtract eigenvalues lambda. So, usual method is you subtract lambda in all diagonal element. So, here diagonal elements are 0 and 0. So, 0 minus lambda, 0 minus lambda, of course, you have this. If you find the determinant, it must be equal to 0. So, yeah, then minus lambda into minus lambda is equal to lambda square. If you multiply this and subtract I, I into minus I is equal to minus I squared, which is plus 1. So, you are subtracting this element. So, minus this will become h cross squared over 4, which is equal to 0. That means lambda is equal to plus or minus h cross over 2. Then you have to find your next task is this is the eigenvalue. It will be either plus h cross by 2 or minus h cross by 2. Then you have to find the eigenspinor. So eigenspinor is, the S5 matrix is h cross over 2, 0 minus I 0. So this spinor matrix, that is column matrix is alpha beta. Now our task is we have to find alpha beta. Then you know the eigenvalue. Eigenvalue is here we have seen plus or minus h cross over 2 multiplied by this column matrix alpha beta. So you have left hand side with this SY matrix multiplied by this spinor matrix. Same thing is right hand side. Here it is eigenvalue multiplied by this matrix, column matrix alpha beta. Now we will find the spinor. So just now we have seen that H cross over 2, 0 minus I 0 multiplied by this column matrix alpha beta is equal to plus or minus H cross over 2 alpha beta, this column matrix. Now you equate the right hand side. First, this H cross by 2 and this H cross by 2 will get cancelled. So now you multiply this first row and column, this column, which is equal to uh, I alpha. In the right hand side, you will get minus I beta, sorry, minus I beta. If you multiply this row and this column, you will get minus I beta. Uh, so the corresponding element, first element in the right hand side is plus or minus because we have removed h cross over to both sides. So this is plus or minus alpha. So naturally we know the modulus of alpha squared plus modulus of beta squared must be equal to 1. So here minus I beta is equal to plus or minus alpha. So I can equate to beta in the replace beta in terms of alpha. So naturally modulus alpha squared plus modulus alpha squared, that is 2 times modulus alpha squared is equal to 1. Then that means alpha is equal to 1 over square root of 2. So the spin plus matrix, spinor matrix uh, for spin up, that is chi plus, which is equal to this eigenvalue, that is 1 over square root of 2. Uh, here we know this matrix is alpha beta. What is the value of alpha? Alpha is 1 here. Alpha is 1. Of course, alpha is 1 over square root 2. So I have taken 1 over square root 2 outside. So alpha value is 1. Then what is beta? This beta is I am using I, that is this is spin up. Similarly for spin down, I am replacing I by minus I. So these two are the spinor matrices. This is for spin up, this is for spin down. Now the section P is if you measured SY on the particle in general state chi, that is equation 4.139. What values might you get and what probability of each? Check the probabilities and add up to 1. Note A and B need not be real. So now the equation 1.4 sorry 4.139 says chi is equal to the column matrix A B, which is equal to A multiplied by chi plus. Now, just now we have seen what is chi plus and chi minus. So P plus P chi minus. Now you try to find the probability amplitude for spin up condition, that is C plus. I am labeling it as C plus, which is equal to chi sub plus chi. So just now we have seen chi. This is a complex conjugate. First value. This multiplication is this is complex conjugate, and this you will take as it is. So complex conjugate of chi plus is this is actually the row matrix. Just now we have seen chi plus is equal to we have seen chi plus, not lambda. Chi plus is equal to 1 I. This is a column matrix. So, to take complex conjugate, column matrix will become row matrix and I will become minus I. So, this is, and chi is A O B. So, then if you multiply this 1 and I, you will get A minus IP. Of course, you have 1 over square root 2. 1 over square root 2. You are keeping as it is. Just you multiply this row matrix and this column matrix. So, in order to find the probability, you take the modular square of this probability amplitude, which is equal to 1 over 2 A minus I P square. Similarly, for spin down, probability amplitude for spin down is you will get if you multiply chi minus with chi. So, just now we have seen chi minus is equal to that is 1 over square root 2. 1 minus I. Uh, this is the column matrix. Here also, of course, you will get 1 square root 2. I forgot to include this here. So here also 1 over square root 2. So chi minus is 1 over square root 2, 1 minus I. Just now we have seen. If you take complex conjugate, because always the this first one is complex conjugate, then that will become 1 over square root 2. This one column matrix will become row matrix. So this minus I will become plus I. Of course, chi is A, B, column matrix. So if you multiply this row matrix and this column matrix, what you will get? 1 over square root 2, this is A IP plus IP. So, if you take modular square of this C minus in order to find the probability, then which is equal to 1 over 2 because you are squaring it, modulus A plus IB whole squared. So, now as per your problem, you have to add both, sum up both, and we will see what will happen when you sum up. Just now we have seen C plus modulus C plus square. That is uh, probability of having this spin up is of A minus P modulus square. Similarly, C minus modulus square we have seen of A plus modulus A plus IP square. So now if we add both, this technically A minus IP modulus square can be written as this A conjugate, complex conjugate, A star plus IP star into A minus IPs. Because you are taking complex conjugate, so plus will become, sorry, minus will become plus, plus IP, and you are multiplying with the A minus IP. Similarly, this one, maybe I will use different colors. So this is the second term, a plus ip modulus ip squared can be written as a star minus ip star into a plus ip. So this can be written as from the definition of a plus ip modulus squared, you can write like this. Now you have taken off as a common thing. Now, if you multiply and simplify these two expression, you will get modulus a squared plus modulus p squared, which is equal to 1. So, the probability, total sum of the probability, that is spin up, spin down, is 1. And part C is, if you measured sy squared, what value might you get and with what probability? Naturally, sy is equal to, the sy is equal to h cross over 2. H cross over 2. So if you square it, you will get h cross squared over 4. Naturally, the probability is must be 1. So this sy squared eigenvalue is equal to h cross squared over 4 with probability 1. Thank you very much for watching my video and supporting me continuously. Thank you very much.